There, it's Jamie again. Welcome back. In the last video, we created a forecast for a time series that had seasonality and a trend, but we only forecasted based on the seasonality. So you can see in our plot here where the blue or the solid line is actual sales and the dashed line is our forecast. Our forecast has begun to consistently underestimate sales because we're not accounting for this upward trend. So if you have data with seasonality, but no upward or downward trend, using only quarterly or seasonal dummy variables is fine. But if your data also has a trend, it's not going to be sufficient. You're going to end up with a forecast that is inevitably going to overestimate or underestimate the actual series. That trend. Well, if you've got this spreadsheet set up, the easiest thing to do is to just make a copy of it. We're going to move our copy. I'm going to create a copy and I'm going to move it to the end. I'm going to click OK and it's just going to duplicate this sheet. And I'm going to change this title to Smartphone Q and T. So I'm going to create quarterly variables and I'm going to include a trend. And I'm going to change the title here in my little notes. Instead of it saying forecasting seasonal data with linear regression, how to use seasonal dummy variables and a time trend to estimate future values. That's what we're going to do here. We are going to make a new forecast. So I'm going to clear my forecast, my error. I'm going to leave my formula for the squared error. Actually, I'm going to leave all of this. I'm just going to clear my forecast. Right, my error term now is equal to sales minus something blank, but once I get a new forecast in there, all of this will populate. Then I'm going to come down and I'm going to take my old regression output. I'm going to delete it. Time variable for a time trend. We have it here, but it's in the wrong spot. I'm going to move it. I'm going to insert a column. I'm going to take this and I'm going to copy and paste. I'm just going to cut it. I'm going to place it in a new spot. In linear regression, in Excel, all of our X variables need to be next to each other. As a refresher, our Y variable is sales. And now time is our X1. Our quarterly dummy for quarter 1 is our X2. Our quarterly dummy for quarter 2 is X. And our quarterly dummy for quarter 3 is X4. Let's add it and just label these. So we've got Y, X1, X2, and X4. That's linear regression. Data, analysis, regression, okay. I'm going to clear everything out and try again. So my Y range is my sales. And my X input range, the time variable, and all 3 of my dummy variables. Keep in mind that in this area down here that I've shaded as future, I'm not putting those numbers into my regression. Because I'm referencing row 4 where I have my labels, I'm going to select labels. And then for my output range, I'm going to place it down here. I'm going to click OK. And then here's my regression output. For the moment, actually, I'm going to ignore everything for my coefficients. We're going to actually ignore everything else for the moment. Eyeball the p-value that they're statistically significant. Coefficients are the betas in our regression model. Our intercept is 6.07. Our time trend variable is 0.15. What that means basically is each successive quarter brings an increase in overall demand of about 0.15. In this case, it's in 1,000 units. So we can see a pattern of increase, and then we're going to overlay that with seasonal variation as in comparison to season 4, because that's the omitted group. So the quarter that's left out, or if you were doing monthly dummy variables, you'd have 11 dummy variables to cover 12 months. When you left out, the technical term for that is the omitted group, and we interpret each of these coefficients as in relation to that omitted group. In relation to quarter 4, quarter 1 has lower demand by about 1,360 units, or is 1.36 thousand units, whereas quarter 2 has demand less than quarter 4 of a little over 2,000 units, 2.03 thousands. And quarter 3 has demand most similar to that of quarter 4, but it still is a little bit lower by about 0.3 thousand or 300 units. So let's plug this in to create our forecast. Our forecast is going to be equal to our intercept. Anytime you reference any coefficient, give it an absolute reference. And we're going to add to that beta 1 times x1. So beta 1 in this case is the coefficient of our time trend, multiplied by x1, which in this case is our time variable. And I'm going to add to that beta 2 reference times x3, and then the last one times, and I want to click x4, but I can't get to it because the equation's in the way, so I'm just going to enter G5 because that's the cell that it's in. And I'll hit enter, and our forecast now is much closer to our original value. In fact, we still overestimate, but only by 0.05 units. I double-click this. My entire forecast repopulates. My error and my squared error repopulate. And now we can see we have a much better forecast. And look how much closer it tracks the actual data. It tracks both the seasonality and it tracks the trend. On average, we can see that demand increases by 0.15 each quarter. Quarter 1 is about 1.36 lower than quarter 4, because quarter 4 is our omitted group. Quarter 2 is about 2.03 lower than quarter 4, and quarter 3 is about 0.3 lower than quarter 4. Our forecasts for year 5. Unlike in the previous example, we don't have an exact repeat. We're trending upward all the time. All right, let me know if you have any questions or if there's anything else you'd like to see. Have fun with this, and I will see you guys soon.